service. I'm repeating for that. My name is Alfred Nutile. Who here has dealt with AWS at all? All right, cool. Who has dealt with the serverless at all, what they're trying to offer? Okay. And so I have to actually know what I'm talking about. Okay, fine. Okay, I'll start at that level. So we'll dig in from there. All right, so let's see. So basically, they're introducing something called SAM. It's a Serverless Application Model. Has anyone heard of SAM before? Okay. Has anyone heard of Chalice before? How about, okay, serverless.com? Okay, so there's a lot of options out there to do serverless stuff. Serverless is where, ideally, you're just running functions. You're using their systems to trigger events and to save data on S3. You're not dealing with Linux or anything. You're not dealing with security updates. It has a lot of appeal. They're focusing on two solutions, Chalice and SAM. I'm going to focus on SAM. SAM is, in my opinion, it has a little bit of an advantage over Chalice, but I've seen both, and part of the team I work with, they use Chalice. It's open source, but again, this is AWS. Unlike serverless.com, it's not going to work anywhere else, so it's interesting they call it open source. I think because you can get to the source and add commits to it and features to make them make more money. So what I love about it is that you build stacks from YAML files, and serverless.com will do this. Chalice, I don't know, but YAML files, your code is in, your build is in the code. So every time you deploy, you can trigger updates, and that's really key in my opinion. The moment you're clicking in the AWS dashboard to build things is the moment you're going to make your life harder, because you're not going to be able to replicate that. You're not going to be able to go to production. With this few lines of code, and you have a new API gateway or Lambda function or a scheduled task or many things, domain names, whatever. It's amazing. And all of this comes from the benefits of CloudFormation. This is the other presentation I would love to do. And CloudFormation is basically, and I'll show you an example, it's a YAML or JSON file that can, it's AWS's own technology that can do stuff to build resources, stacks, anything you can think of you need at AWS, it can build it for you in one file. And they can all come together in that one file to build everything you need for staging, connect it all together with tags, policies, and everything. And so what I like about SAM is it's built on top of that. So everything you do in SAM, unlike serverless.com, is compatible with CloudFormation. And to me, that's really key if you're using AWS. If you're not using CloudFormation with AWS, really step back and think about it, because your AWS is going to get to be a mess. And no one's going to know anything. Like, what is this for? What is this for? What's the conventions for naming? Why is this named differently? If you don't have some way to centralize that, other people will use other well-known DevOps tools for it, which is fine. I forget some of the names, but CloudFormation has been really good to take care of the AWS like craziness. So why serverless? Why SAM? No servers, simple, minimal work to build services, and you'll see in a moment. You get all the back end of AWS. It's their official framework. You can put forum tasks. If you pay for support, you can do support. They have Slack channels you can get into and ask questions. I get a lot of help in Slack from them. There's some amazing downtime deployments. Like, it will actually take Lambda functions that you're deploying, and it will take 10% of the traffic and put it to your new function because of behind API gateway. And if everything's going good, it gets 100% success rate. It starts moving the other 90% over. I mean, that's for nothing. Like, I write one little line in the YAML file saying code deploy yes or something, and boom, it's doing this. Caching is amazing. Like, I had to build an application that's like, oh, they're going to be voting on these meetings. There's going to be 50,000 users. And I'm like, I don't want to host a server. I don't want to be responsible for that. So I just put up API gateway with serverless and then turned on caching in authentication. And boom, I can take all the traffic I want, have zero downtime with deployments. And I'm not doing anything at that level. I'm just saying, thanks for that little bit of JSON. I'm going to process it with my Lambda function and put it somewhere I care about in a database or something. So it's just all these little things. This was like a checkbox, or in AWS is like a little CloudFormation little setting. Great for batch processing. Again, I'll talk about how it's not all or nothing. It could be serverless plus your framework. Like, we have a serverless solution, but then Laravel's doing the front end JavaScript interface to Elasticsearch. So you don't have to do one or the other. Scaling built in, and then CloudFormation. But then why not, right? Serverless has its problems. A whole new set of variables. I had to use Postgre with Python and the Lambda functions, every time I deployed it, didn't work. You Google a bit and you find out, oh, you have to pull the Python, the Postgre library for Python out of GitHub because the special library then works on Lambda. And it was like, okay, that was a pain in the arse. I spent how many hours? But, so, you know, we all know this. Every freaking technology has a flaw. So there are flaws. It's not perfect. SAM is not as mature as serverless. I've hit a few moments in SAM where I want something that I know CloudFormation could do and AWS could do, but I couldn't do it in the SAM syntax. And I'll explain that as we dig into things. So it's not as mature as serverless, so you sometimes will miss out on some of the more advanced features that you could have done on AWS. And you could get around that in many ways, but if it comes up, it's only getting better. You're locked into AWS, you're basically building stuff for AWS at this point. If you want to switch with serverless, in theory it could build for Azure or Google. With SAM, no. Is that a big deal? It could be. It's a tricky one. Memory limits, you have memory limits with Lambda, runtime limits. I don't think these are a problem because if you're writing Lambda functions, they should be small, and they should use the gluing effects of events that you get from S3 in other systems, so that you can do one thing, put it on an S3, trigger an event, do another, and so forth. Language limitations. I don't know if this is true anymore, but Lambda had some language limitations, but now they have Firecracker, I think it's called, and you can even do PHP if you wanted to. And it's very hard to test locally. I'll go over that in a moment. It's not perfect. Okay. Now, one thing to consider about serverless is we've all worked on monolithic projects, or things that aren't even monolithic, but you have a big team trying to find out where can they start coding, what can they work on. It's a great chance to break things up. You could easily say, hey, we need this new image processing system. It's tempting to say, well, just put it into this website that we keep building and doing more and more things. And it's like, no, let's move that off, build the whole back end here, and then let the front end just send data to the API. And so you can have one team really focusing on this, deploying, and they can focus on that code base. It could be one developer or two, and keep it separate and start growing in that, like, I have this big application, I want to break it into smaller things. And again, you get a better deployment workflow because you can deploy that little thing better. So just remember, serverless is not all or nothing. You can slowly break it down, any application in the serverless solutions. Again, CloudFormation, it should just be used everywhere in your AWS stuff for almost anything you do there. And I'll show some code in a moment. One other thing that really turns people off from AWS in serverless, I noticed, is the pricing. I got a bill for, like, it was horrible. I got a bill for like $3,000, right? It was all my fault. I pressed the wrong server size. It was my own account. And I get a huge bill. And I talked to them, and they helped out. They were really generous. I'm like, it was just me. AWS can be scary. It wasn't like a mistake on their part. It was all me. But they do give you tools for managing bills. It can project cost. You can get alerts if it goes too high. And what's really cool is you can tag every single resource. So you can basically say, customer foo, here's everything they've used, and this is how much they're going to be billed, right? So you don't just get your bill. You can break this down. So they have tons of awesome tools to deal with Lambda, serverless, whatever, if you want to start building stuff in AWS that way. They have their calculator to help with, predicting cost. It's not amazing. But one thing with Lambda and serverless, which we'll talk about in a moment, I had to do some, predicting of like, how much is it going to cost us? We might get 5 million hits a month, and we need 128 megs of RAM, and it's going to run for that much time, and it's like $106, right? I don't have to. It's like a server on AWS, even if you use a cheap one, might cost 40 or 50 bucks, but you forget, like, it takes us a lot of time to manage it, and every time there's an update. Like, how many times have we shown up to work only to have a huge known zero-day vulnerability with Linux, and everybody has to stop what they're doing and go update the servers? It's no fun, and it just blows our day. Just a reminder, like, this can be cheap, and this is way too long. Your Lambda function shouldn't run 10 seconds. If it is, it's technically, I think you're doing too much in that one thing. You should be breaking it out more. But that's still that's really cheap for 5 million hits and to do something. So So I'm going to start walking through how to make something, and I do want to log in to my AWS as well to help with this, so I might have to do that in a moment. I should have done it before, but I got distracted. But we're going to make a Lambda function, a serverless function in just a moment. So with serverless, with SAM, you can do a lot of things. You can make Lambda functions, you can schedule tasks, so every hour you do something. You can build APIs just like that. You stand up an API gateway, you can have a post or a get, you can receive data. You can then even cache a GET request, but more importantly, you can integrate with their authentication system called Cognito, and before long, you have a it might even be free, a free OAuth server. You have them providing you an OAuth server to deal with users, up to 50,000 users, if I remember. And you don't have to worry about anything. Like, it's not going to go down. If it goes down, and you tell your boss AWS is down, like, there's a certain forgiveness point, right? You know, and it's like, and I didn't, like, again, this application I had to build, this whole project I was on, 50,000 people trying to log in and the server's down. I don't want to deal with that. I don't want to try to sleep at night with that. Sure, you can do it with load balancers and blah, 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 but I just didn't want to. And with their API gateway, with one check of a box, it would then use Cognito to do authentication. And Cognito plugged in for us into our SAML backend. So you could do SAML or Google or Amazon or other authentication systems. It was just like that, that we were able to do authentication, which was a load off our plate for so much. And then we could just focus on the requests coming in. They can connect to databases, Kinesis Firehose. If you just I need so much data coming in, I just don't want to think about it. You put Kinesis Firehose in front of anything, and it just takes the data and says, what do you want to do with it? It doesn't matter how much you throw at it. Amazon did their own thing with this, where they would look at all the Twitter traffic that had the Amazon tag, and then they would firehose it to Firehose, and then they would analyze it with their machine learning API to see if it's a positive or negative thing. And honestly, that sounds hard, but it's not. And the machine learning they offer is also amazing too. You could plug that in, and within almost no time, you can have sentiment analysis of these things. It was really neat to see them using their tools to build something. SQS, SNS, and Alexa. So you can hook up your serverless stuff to put stuff into a queue, or put stuff into SNS, or S3 that then puts it into SNS, so anyone can subscribe to it. Emails, SQS. And so forth. And then Alexa, of course, is a part of this whole serverless stuff where you can build Alexa apps to do things there. I haven't done anything there. Nothing's come up business-wise. Any questions so far? Anything people already know or thinking or want to add? All right. Yeah?
What would be an example of something you use Lambda for?
Yeah, you jumping ahead. Hold on. But if I don't get there in a moment, if I don't get there, we'll bring that one back up. So what I'm going to do is I'm going to jump into CloudFormation, and I think my Lambda example is pretty lame. So let's go back to your question for a moment, okay? Okay, here's a good example. We use Adobe Analytics at work, right? So they didn't have much of an API, if I remember, and I was only part of this project. So what we did was we had them dump a big CSV file onto S3, right? And so when S3 gets a new file, you can easily say, S3 on object creation, I want you to do something, and it could trigger that Lambda function. So Lambda then got the path to that file and could say, I'm going to go get this file and process it. And so at that point, Lambda could open up the CSV, and it was maybe 100,000 records. For every line, it would then trigger another Lambda function. See, because that function's job is not to open and iterate and process. Its job is to open, iterate, and then distribute the work. And so, that's a really good example of where it was just amazing. Like, you could just string all these things together, not worry about running out of resources, not worry even about the complexity of events. Like, S3 just works. I don't know if you guys have used S3, but it just does everything, right? It's amazing.
Run out of resources because it scales on its own.
Yeah, the only time S3 just scales. The internet runs in S3, so it just scales. I don't know how the frick they do it, but it just scales. So you don't worry about any of that stuff. I think you only worry about it if I set my Lambda function to only have 128 megs of RAM because I'm trying to control pricing and quality, and you go over that, you might hit something, but then you're like, look at the logs, and you'll be like, I ran out of memory, and you would just bump it up a little. Or, again, break things down small enough. And I'll show some of this in a moment. They also have this service that is, it's an interesting concept. It's, I can't remember the name. It's like step or something where they actually... Step functions. It's a concept of like this function is doing this, the next step is this, unless something goes wrong, and then this. And they help you diagram it out and track the whole process through.
That doesn't count towards your time either.
What?
Step function.
Really?
Yeah.
Yeah, so some of these things are glue, like Cognito, they're just giving away for the most part. It's bizarre. I mean, of course it makes sense. Another Lambda function, I mean, there's just so many. Here's a really silly one, like simple one is, they wanted a very simple API, so I put API gateway in front of it, and the gateway says this person wants the tips file, showed all the tips for using the application. Well, it would have been tempting to put that in a database, but I just had the Lambda function, grab it from S3, give it back, and that function could do that really quickly, and within 3 lines of code, I had an API I never had to think about again. They have this one Lambda function you can get online where it does clam AV virus scanning. So every time someone puts a file on S3, it triggers an event to trigger that Lambda function to grab that file, scan it for viruses. If it finds a virus, it moves it into a quarantine place and puts back another file in its place saying this has been quarantined. I mean, that's pretty cool, and you could just plug it in. So there's a lot. I mean, it's almost endless what you can do. I think in the end, anything you can do in your web application, you could start thinking about using Lambda for, honestly. So this last project, if I could have figured out how to serve the JavaScript interface on S3, I would have. I just didn't have time. And why then would I need Laravel at all if I didn't, it would have been a nice moment of going all the way. I just couldn't do it, right?
S3 is the storage.
S3 is an optional storage. So S3 is a place you can store JSON files. So I can take a file, dump it as pure JSON, and boom, it's no different than what you would imagine. And S3 actually has Athena, which is a MySQL type, or not MySQL, it's a SQL type interface to your file system. So you can query the files on the system. But, you also have RDS, which is MySQL or Postgres. You can store to a regular database. A lot of people use Dynamo, and now they have a replacement for Mongo. So there's so many options you can plug in. I use S3 a lot because it's just easy, and I'm usually just storing JSON. And then from there, the Lambda function puts it into Elasticsearch for me from S3. So I have a backup. I have S3 triggering the event. And if we ever have to re-index the Elasticsearch, we can just grab everything off S3. So it's kind of a nice little backup. All right, so let's see here. Oops. All right, so let's just jump into an example. I'll start with CloudFormation. CloudFormation can build anything on AWS, but this is called a transform. And this transform just means that AWS is going to now treat this as the new serverless process. So you're going to write very, very simple templates. But when we go look on the website, it's transformed it for you automatically to be more complex. And so this is what a template can look like, and we're digging in a moment. And so you just have this helps them out, and then you have your description and parameters. I'll show the form. Parameters are pretty cool, and I'll show the website. You're basically making a form that you put in values to, so you can have production and staging. And those parameters allow you to dynamically build stuff and use them down here. You have global, which can apply to all your things. And then you have the resources, the things we're building, which is, for example, API, some API stuff for API gateway, or some settings for it, and so forth. I'll dig in a moment in this. But that is basically how the CloudFormation template begins. And let me see. I'm going to show it in the editor, because that's what my notes tell me to do. So this is the same template without all the expanding collapsing. So you'll see, when we go to the web interface, if we want to, now I'm going to run all of this. Actually, I'm not going to run any of it because I know better. You would just run, you would run this at the command line, and I'll show you the commands to build and deploy. And I'll talk about Travis and CI deployments. But then I could pass parameters in. So app name, app env. So all of our stacks have those two parameters, so then when we build things, they dynamically can name their resources. After you're done, and then you have billing tags, like we have a reference tag so we can build things. And I'll show you where these show up in a moment. So if you look up down here, we have a global setting. So for every function, we want to use Python 3, because there's a lot of emphasis for Node.js. I just don't find that language easy for me to understand and use. So I'm using Python, and I really enjoy how easy it is. But I'm now saying all my functions use Python, and I'm passing environment variables in. So I can pass the AWS environment by using that parameter I used above. And so you see there's a weird syntax there. That exclamation point sub is part of this. There's intrinsic functions in this templating system. So now that's going to substitute out the parameter up above and other things. And there's a lot of these intrinsic functions that make this templating system pretty powerful. I can reference other CloudFormation stacks. I can do dynamic conditioning based off of a condition parameter up above. So you really can do a lot in these templates. If we scroll down this template, here's the resources. Now, this is a resource, I call the Example API. It's a serverless function, and it's a type of serverless function. Now, that's what we're working on, but it could have been type S3, it could have been type SQS, it could be anything. And then it has properties. Well, I'm going to cover these properties in a moment, I'll cover those in a moment. But it has its handler, its runtime, where the file is. But here's those dynamic properties again, parameters. I can now name my function dynamically and find it. I can tag it so I can find billing issues or who owes what money. I can attach pre-existing policies to it. Lambda, AWS has a whole bunch of them. But this is the hardest part about AWS in my opinion. They have tons of policies and IAM stuff, and it can get hard. I mean, how do you apply it? Who's it applying to? Is it applying to Lambda? It's the tricky part, but if you get it, you can appreciate the security and everything. But this one, it's just saying, hey, this Lambda function can do Lambda execute. This Lambda function can do API or VPC access, whatever. I mean, there's the whole SAM repository has hundreds of examples. I'm copy-pasting most of this, by the way. And I'll show you some of that later. Here's some environment variables. I want my Lambda function to be able to spit out and know what app environment it's on. So now it's going to have access to app env. So that's a really nice way to pass in environment variables. And finally, underneath all of this function is the serverless type. And in this case, it's a type API. So I'm making a Lambda function connected to an API gateway. And in SAM, the Service Application Model, does everything else for me to build this out. And so now right away, I'm about to make an API gateway to this route using GET. It's going to connect to, this is another intrinsic function, to connect to this particular setting that I want everybody to have. And that's it. I've now built a route that will trigger Lambda for me. I didn't have to connect Lambda to this all. It just is there because I made that serverless function an API. I could have made it a scheduler. I could have made it other things that they have, like simple database or table. But that was how easy it was for me to then build this API. I can now send traffic that it could just scale. I can get traffic at this route. It will give me a DNS record, and then it will connect to the Lambda function. And I'll explain how you deal with the request in a moment. And this is not necessary. I pulled it out because of the recent project I was on, but you don't need this at all. You could have removed all of this, and it would have just been more standard. So, this is just nothing really worth worrying about. But that is all you need to just build an API that will talk to Lambda. Any questions on that so far? No questions, okay. That could be good or bad, but we'll see. All right. So, and this is about step functions, but I wanted to bring that up again, but I already talked about it earlier. But this is just, Lambda is so I have my boss's name is Mike Lamb, so sometimes I type Mike Lambda. It just drives me nuts. I say the word a lot, but Lambda, it almost seems it seems like serverless is Lambda. It's funny, maybe it is. Lambda is just those little functions that will take things from one process to another. API gateway to Lambda, Lambda to Elasticsearch, or Lambda to S3. So Lambda becomes this little mechanism, this gear that moves things along. Break your functions up into small functions and glue them together with events. So we have a request coming in. It will talk to Lambda. Well, don't do too much. Put it on S3. Trigger an SNS. And then what's really nice here is if you think about it, this is your application. other applications can subscribe to SNS, so you have complete separation of application responsibility. It's a nice way to build things, because at that point you're saying, I'm done, go subscribe to SNS and you'll get what you need, right? All you have to do is have contracts between those two applications to say, my JSON payload is not going to change. And you can be pretty bold with your deployments and everything, knowing you have this agreement with each other. So does that make sense to everybody? All right. Now, so Lambda can be, it doesn't have to be a class. I'm going to show Lambda as a class, as I like to write in classes. So Lambda, in this case, is just a Python file that's going to be a class, and when it gets called, it's going to say, give me that request of yours. Now, what's a request? A request is anything you send to that API plus some other metadata that AWS gives you. Just JSON. And it can return something from that request. So you can really build code here well, because you can just take this class, you can hit it with your test, and you know it works. And I try to explain to the people I work with when I train, you've got to treat code like a bunch of Legos. Like, this needs to work perfectly on its own before you try to fit it into the other thing to eventually build that Lego model. Get all your stuff working, get it tested, know as much as you can that the message in is going to be handled and the message out is going to be handled. You can plug all these things in. I'm going to show you how this class will then be plugged into another file. Now, I'm going to see, let me see if I have a coding example too. Yeah, I do. So again, basically, and this is, Paul is talking about this downstairs, but you could basically just now, you could be testing your code during the CI build, and this would just test that class does X, and then I can plug it in a moment, right? So, and it's like, okay, so my point is work this way. Take your Lambda functions, work at them as a simple class, nothing to do with AWS, and get it going just right. In this case, I just assert the results. Okay, but let's see what we do with this now. What do we do with this class we just made? All right, so this is the next one. So then we get into the controller. So let me show you guys something. So who uses Drupal here? I don't. I'm not going to raise my hand. Who uses Laravel? Who uses Rails? Right. So every framework we use basically is about taking. This is what's funny too. Is there any chalk? Yeah. So basically, everything we do in our job is to take a request. That's all we're doing, right? So when a request comes into any framework almost, there's a route. And that route says, I'm going to do something with this request. And that route is going to say mostly, here, controller, you're in charge of this route, go do something. So we have our request, and then we have our route and our controller. And what I'm trying to show here is this isn't that much different, okay? We built a stack. We built an API gateway, and that API gateway is basically hooked up right here. So this template file honestly becomes this is our route, okay? And the template file basically says, I'm going to route, using API gateway, anything I get into this main file.hello method. So that main file, in my opinion, becomes our controller, where it's going to say, I'm the main file. Whenever I get a method call to hello, I'm going to do something. So that, that becomes our controller. So you can really think of this that way. It's not that foreign. And then at this point, it will say, well, here's the event. I don't use context ever. I know you can, and I haven't gotten there. But I take the event, and I can pass the event into my class. So here I am pulling up the class. I say foo.yo event, and I can do anything I want at that point with that payload. That result, that event is just a big JSON body with some other metadata I can use, like who sent it or whatever. But I just want to show how this stuff plugs together to, in many ways, the way we're used to. Does that make sense to everybody? How you can really connect all these pieces that way? You have your template file, your main or index file, some people will call it, and you're pulling in all your code, and it's really that easy to build a Lambda function and plug it in. when I said earlier testing could be hard, they have ways to run routes, API gateway locally and everything, but I still feel it's a little bit hard to say, when I even have a validation class in one thing, I plug it in here and it's well tested. But in the end, until I deploy this code, I never know for sure this is going to work, because it's a little bit harder to test. Not impossible. Actually, I could just call that and test it that method. I mean, I should just do that. So, but you can see sometimes it can be hard to know all the way until you push it up there. But hopefully, locally, you're very confident. I like to be 100% confident, or 99%, but I've been having trouble getting that far with serverless. Sometimes I do have to push the staging to verify. But then I have tests there that hit staging. So that to me is how I try to look at and memorize or visualize how this stuff works and how to hook it all up. So then the next thing is like, okay, so we've built this thing. How do we install it? How do we deploy it? I mean, basically at the command line, I would never do this at the command line because we use Travis or any CI system. Who uses a CI system here? What are people using? Travis, Circle, anything else?
Just GitLab.
GitLab. Oh, cool. They all. You're better off saving this for there. And basically, Travis YAML. And I don't know if I show this later on, but Travis YAML will basically run pip3 install, get everything I need. It will then run SAM package. And SAM package will take your template and just create this amazing other template out of it and put it on S3. And then you write SAM deploy, and it deploys it for you. And that's it. I've now deployed this application. And this is, it can be as complex as you want. And every time you deploy it, if you didn't change it at all, it's going to skip over it. If you change just a little bit, it will just change that little bit. So it's pretty neat. And it's all just using the API AWS has of CloudFormation, honestly. That's all it's doing. And I'm going to log into AWS to then look at this. Let me know if anyone has any thoughts, though, or any questions. Oh, that's my Amazon shopping. I don't want to go there. Sorry, I totally meant to get this going before. Here we go. All right, just so this isn't so scary or abstract, AWS has a decent API UI. I used to make fun of it a lot. It seems very enterprisey or engineeringly, like it's really hard to follow, but it's getting better and better. But basically, what we did, and here it is, CloudFormation, is when we sent that request up, it basically talked to the API here. And let's see if this is it. Yeah. And it built that stack for us. So sorry, I keep saying that. It took that template that we created here and ran it. And it actually shows you an option to view it in the process template. This is what they turn it into. You can write in JSON or YAML. I enjoy YAML more than JSON. I thought I'd enjoy JSON more, but it gets a little bit harder to read. And then they make it more complex because we're really doing more. But SAM is allowing us to write less and then do more because they process it for us. And what it did was it does all these events, which is, it builds or updates or adds all these different resources that we had. It shows you all the resources we made, so you can easily find them. It allows you to do outputs, like I can output the secret or something that I want someone to have access to. And then these are the parameters. So if I was to go back here in the UI, and I wouldn't do this for serverless, but I do this all the time for other things. I can update the stack. I'll use the current template. That's what I was talking about with these parameters, how it's just basically a form that they allow me to make with CloudFormation scripts. So With serverless, you wouldn't do this as much because you're building it and it's making a more complex version of it. But just so you can see, that's what's really happening in the background. It's sending this to CloudFormation and going to build all of this out for us. And again, if we go to API Gateway,
Can you show the template designer?
I will, but I'll tell you if you ever use it, I'll be surprised. So hold on a moment. It's more work, and it's bizarre. Like, I can take, there's so many examples of CloudFormation templates that I'm just pasting away. But if you want to go in the designer, so we would do
I like it more because it lets you know how everything's connected.
Okay, yeah, that's a good point. So you could output that to even show as like a project asset, you know, right? Because you can show like to the management what you're doing too. Yeah, that's a good point. They let me do this here. Oh yeah, I can go replace current template.
You go back to the template. There's a button in the top right.
Okay. Back to here.
Yep.
Cool.
You go to the template section.
Ah, thank you. View and designer. I always thought this was going to be really cool, but again, I've just never used it. And then our stuff got so big for some of the bigger stacks that it just became too hard to read. Sorry. So it starts to print out, and I'm surprised. There we go. It starts to print out this like map of all your true AWS resources, how they connect and where they can talk to each other. It's interesting. And you can build it all in there and then export it. But remember, we made an API, so if we go to API Gateway, we now have our API that we could, let me move this over a little. So here's our API. Let's just click on it. And we see our API example. And we can dig into it more. If you want to troubleshoot or just get a sense of things, you can run tests against it, and so forth. So it's not that hard to dig in and see what's going on in the background. And you get all these feedback and statistics or stats of what's going on. And then the Lambda we built is right here. And I end up here a lot when something's not working. I'll go here and click on my Lambda function, and I could run a test on it if I wanted to see why is it not running. So I'm just going to call this test to save a JSON payload. And I could hit it with a test if I wanted to. Or more importantly, I could go into logging and see like, okay, what's going on here? And it would typically give me output of errors or whatnot. Or I could just hover and get into here really quick and view at the particular logs for that function, even limit it by range. So I find myself in here a lot when I get stuck on something to see what's going on, especially when I'm first building a function. So that's a good example of like how the UI can surface what you're doing with this stuff. So, any other questions about the UI? All right. But that's it. Travis, whatever, can do it. Your developers can just code, deploy, and it triggers any new updates. Again, running locally, you can type sam local invoke. This is the name we gave the resource, and you can pass it in JSON, and you're going to get results as if you hit the real API. It's not 100%. Like I said, I find it still falls short. It might be my setup. I've talked to people in Slack, and I think it could be better. I think it might be my setup, but you could really get a sense of your stuff working. So when you push to Amazon, you know it's going to work. Running locally, you can actually start the API, sam local start API. But again, I start it, it runs. I'll hit it with Insomnia or Postman or curl, and it will actually work. But then it'll give me an error. But then I'll look in the logs, and everything worked like I thought. So I still feel like there's a disconnect. But you can do it. You can run API Gateway locally. It's pretty cool. It's all using Docker. They're just locally sandwiches Docker containers mimicking AWS. It's really neat what they're trying to do. So let me see here. All right. So again, you do have alternatives. Google, Microsoft are doing some amazing stuff, and serverless.com works there. They might even have their own serverless. those are things to consider. We're sold on AWS where I'm at right now, so we're not changing. So I'm trying to use the most of it and not worry about that. Maybe I'll regret it in a few years, just to me talking about how to switch off AWS. But that's where we are right now with that. Here's some links to consider. So AWS has amazing. Well, not amazing. They have good. Okay, so there's their docs, but there's also a GitHub version of it, and the GitHub version has tons of examples. It looks like I didn't do the GitHub one, but once you find the GitHub version, you'll have tons of examples, and I'll pull up some in a moment. But you can get more information here. Here's some more document. They actually just released a repository, so I can go to AWS's repository for serverless, and I can find ready-to-go serverless functions, image processing, whatever. Like, I'm amazed at what they have, web scraping and so forth. So there's really some cool stuff going on where you as a shop can just pull this thing down. Like the virus scanner, I just installed and I was pretty much ready to go. Serverless.com is to look into. Pricing, that pricing example I went to show you what your Lambda might cost was at Dashboard. So there's just some things to think about there. But I do want to, and I have like 2 more minutes, so let me just show you one more thing. Let's see if I can get in here. Oh, that's funny. It's because you guys are watching. Hold on. There we go. Actually, it was me. I'll just do it here. Okay. So if you go to their GitHub site, you can grab a whole bunch of, you can link into their docs or click into their docs down here. It's decent docs. But what I want to show is like, there's just tons of examples. So if you go into here, you can see like, and the screen's not that great, but you can see like, here's a ready-to-go Alexa skill or Hello World or image resizer. And like I said, they've moved all this to an actual like web UI for repositories that you can get actually like, working stuff. But this was a great place to go for me to learn how to do some of the things. So I would go into that folder or apps, and I would just open up one of the files and just start thinking about it. So here's like a simple Hello World, and they used JavaScript, and I could go in there and see what did they do, how did they get the content out of the request, how did they build that. So you definitely get a lot of examples to get going on how to use this. I mean, look how long this list is, and they're all I've looked through a lot of them. But yeah, just a reminder there that their AWS Labs is a good place to find that stuff. But yeah, that's about it for serverless, Sam. Any questions at all so far? Because there was a few good ones. Just any more? All right. So that is it. Everybody's done with their day. This was the last one, right? All right. Cool. Thank you.